In progress. All right, we'll wait another minute or so and we'll start.
Wait,
Who did the problems?
I have to go for a second.
Okay, that's fine. Who did
As
the
you
problems?
know, me and Levi always did them.
Okay, good.
I'm pretty sure Emma did them too.
Yeah, she did them last Friday, so hopefully she remembers them. Let's see. You know what I've noticed is since we started doing the advanced problems, when me and Emma do her normal math, if we go over exponents, it's just so easy now. Do you guys notice that at all?
Yeah.
Yeah. It's really easy. Okay, I'm going to attempt to share my screen. Let's see.
Attempt to share your screen.
I mean, sometimes it doesn't work, so.
I'm back.
Alrighty, perfect timing. All right. Welcome to Pi Day, everyone. You're more than welcome to eat pie during class if you've got it. Does anybody have pie today?
Nope.
I don't have pie.
Anyone making pie today?
Nope.
Probably not.
I didn't even know if it was Pi Day.
What? 3.14. It's March 14th.
Well, yeah, but like I never thought of it.
All right. Clear my screen, everybody. Thank you. All right, I'm gonna write the homework on here and the lucky people that want to actually explain it to everyone. All right, can you guys see that? Or is it up too high?
I can see it.
Okay, cool. All right, square root of 27. Who wants to go first? This is the easiest one. Anybody?
3.
It's not 3.
Is it 1?
Oh, that one. Let me get my paper.
Who wants to write on the screen?
It's 3. It's 3 times the square root of 3.
That's right. How'd you get there?
Oh no. All right, let's see. Okay, this was very. I almost.
Show your work.
All right, let's see. I can't see. All right, here we go.
So we'll say.
So we have the
I can
little
do it.
pi thing.
Okay, go for it. Whoever said you can do it, go for it.
And that equals 3 to the second times 3 squared times 3. Oh, that's terrible. And that's the same as 3 squared. 3 the square root of 3 squared, which is also the same as just 3, the square root of 3.
Yeah.
And then that also equals, then you could write that as just, you could just write that as 3, wait a minute. Oh, and you could just write that as 3 because 3, the square root of 3 squared would just be 3 because you're just taking away the square.
That's
So
right.
that just be 3 to the square root of 3. 3 times square root of 3.
That's right. So basically, what this whole exercise is about is pulling out as many numbers from under the radical sign as you can, right? It's almost like a type of reducing for radical signs, right? So how much can we
Why are
actually
there
pull
so many
out?
threes and squares?
So essentially, if you want to just factor 9 times 3, right, equals 27. As soon as you have a perfect square, and that's a 9, you can actually pull it out in front of the radical sign. So the square root of 9 is what, everybody?
3.
3.
Three.
3, and then what's left under the radical sign is what Levi said, just the number 3. Okay. So sometimes you can break this down, which is going to be important. And this is these problems are great at exercises with factoring. Okay. As we'll kind of see as we go farther with larger and larger numbers. Okay. So we have the cubed root of, not a 3. Cubed root of 28. All right, who wants to do this one? This is
I
some
want to.
factoring. Okay, go for it.
Okay, so the first thing you do, you turn it into and dang, I forgot the word's called.
And that gives you 7 2s. And since the 3 is next to the radical sign, it's 1 over 3, so that would be 2 to the 7th to the power of 1 over 3.
Okay, so we figured out that when we factor this, right, and we keep going down the line, right? Right?
Mm-hmm.
Okay, we keep going, da, 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 da. It's actually going to be 2 7s. So 2 to the 7th is the exact same thing as 128. So we just put it in exponential form, all right? And then you're going to take, right, like Emma said, this radical sign away and put it to the 1/3, right? Okay, keep going. I couldn't remember, is it Emma doing this or Lola doing it?
I was the one explaining it.
Oh, okay,
I
go
am
for
really
it.
confused.
Okay, what's confusing?
I thought 64 was like a square root.
Oh, good point. Excellent point. What do we have here?
Tacos.
Is this a square root? Yeah, it's a cubed root. But that was a great observation because at any point during this factoring, if you see a perfect cubed root, you can go ahead and pull that out from the radical sign. So you can save yourself a lot of steps down the line. Okay.
Okay.
So that was a really good point. Okay, so this turns into what? 2 7 over 3. And then this is an improper fraction, right? That's an M. Improper fraction. So what do we need to do with, how do you make that a proper fraction?
You have to split it up.
Okay, how do you do that? 7 over 3 equals what?
On
2.
How many, that's right. How many 3s are in 7? There are 2 3s with a remainder of what?
1 over 3.
That's right. Okay. So now we can pull this out. What is the answer to 2 squared?
1.
That's just 4.
4.
2 squared is 4.
4.
And we put this number back under the cubed root sign, and that would be our answer. 4 cubed root 2.
That's what I got
All
to.
right.
Yep.
Okay, cool. All right, who wants to do number 3?
Wait, let me
Now
see.
this one has one of the hints that Grace was talking about, where you can kind of. All right, this will be the 4th root.
Wait, are you asking for 1600 to the 4th power?
Yeah, well, maybe, well, I wouldn't actually.
I can do
Let's see.
1600 to the 4th power.
All right, what 2 things multiplied together would be 1600?
16 and 100.
Okay. So when we start factoring these out, what are we finally going to get for factoring? What's our number? All right.
10 and 10.
Yeah. What's our final numbers that we're going to get if we don't want to continue factoring? How many 2s are we going to have and how many 5s are we?
I have no idea. Give me a second.
I mean, did someone do this differently? Because that's an option as well.
Yeah, I think he did it differently.
Okay, how did you do it?
So we didn't do that. We didn't do like factorization or whatever. It looks a lot like factorization what you're doing.
Okay, how'd you do it?
What we did, we turned it. I can't draw this from this end.
Here, I'm gonna erase
Okay,
this.
yeah.
My stuff.
So it was originally 4 right here. So we had
Yep.
1, 6, 0, 0. And then the first thing we did, we turned it into that's what we did. We didn't
Oh,
do
okay.
yeah, and then we turned it
That
into
worked.
we put the 2 outside with the root with the
Mhm.
square root there.
Yeah, the 4th root.
10 to 4th root, and then we turned it into 2 times square root to another root in here. That's 10, 2. And then the answer became 2 to the 10.
Wow, that's pretty
So,
cool.
I think my
You have a
conclusion
root
is,
inside a root. That's
I
pretty
think-
cool.
Yeah.
my conclusion is that 1600 to the 4th power is 102,400. I think.
Okay, so this would be the root, so it'd be 1/4 power. So
Oh.
1600 to the 1/4 4th power. So I did 2, I factored. So you'd have 2 to the 6th
I think I did the problem wrong.
times 5. So that's what I get when I factored. And I then put it times a 4th, each one. And then I made it 2, I reduced that, right? 2 to the 1/2 times 5.
Can I do
And I
the
reduced this
problem wrong?
number 1/2. And then I decided to put 2 and all of this under the square root sign. So I got 2, exactly what Lola got. Don't you love how you can do it all sorts of different ways?
Yeah.
Well, I just started.
Okay.
I just started doing these, and I don't really know them very well, so I might not be able to give you any answers on them.
That's fine. You can listen.
Okay.
Or if you have questions, ask questions. That's fine. This is
I'll
a
see in the
safe space.
chat.
All right. Who wants to do the really long number one? Number 4.
Levi should do it.
I think
Yeah.
Levi wants to do number 6.
Levi always wants to do the hardest one, I think.
All right. See if you can, for some reason, erase your
I'm trying to decide
drawing.
between number 4 and number 5. They're both terrible.
Well, did you factor the number 4?
What do you mean factor?
Did
No,
the
he didn't
factor
factor
tree.
it.
Okay. How'd you do
We
it,
did.
Levi?
All right. Oh, I should probably delete my writing up there.
Yes.
All right. So I started with, well, I gotta get my pencil. I started with turning that into into a 525
Okay.
525 to squared times 33.
Wow.
Yeah, I had to
Whoa.
use a calculator for that one.
Yeah,
I bet.
I bet.
And that equals 525 squared. Yeah, it equals 525 squared times the square root of times the square root of 33. And that
Nice.
equals, man, my writing is terrible, but
It's fine.
Fine, we get it.
525. Oh wow, that really sucks. 525.
That's right, because the square root of the
525
square
to
is just that
the-
number. Yeah.
525 squared to the 1/2. I
Right.
don't know. And then times 33, the square root of 33. And then I can just turn that into 525 times the
right.
square root of 33.
Excellent. Man, you're smarter than me. How you got there? I had to factor mine. I had to actually.
We didn't.
So
factor
the
anything.
trick that I use, that if you want to do it the super slow way, right? Is you just do prime tricks. So you
Prime
see if it
factorization?
divides by, you see if it divides by 2, 5, 3, or 11. And this one happened to be 11. So I even started off with 16,000, 165,375 times 11. And I factored that all the way down till I got
Don't you
3
mean
to the third, 5 to the fourth, 7 squared times 11 to equal that number.
826,875 times 11?
You're right. I am. You're right. I missed a step. Thank you for correcting me.
Yes.
And I kept reducing it. So I kept dividing it by 5s and 3s until it finally reduced all the way down till I got this. And then I could put, Then I took out the radical sign and put all of those with a 2 underneath it, right? It's my square root there. and then I can reduce it to what Levi got. You are super smart because I had to then reduce this down to 3 times 7 times 25. And then inside's going to be my 3 times 11. And then I finally could get 525 square root 33. So good job. Way to use the calculator. All right, number 5, cubed root 36, 1, 2, 3 over 2, 4, 3. All right, so this is the one that Grace, you want to try this one because this one actually, the very front is going to give you this 3 zeros is going to give you a clue with this cubed root sign. What can we already pull out of there, guys?
1,000.
Okay, well, it's 1,000 for sure, but what is the cube root of 1,000? Yeah, so we can go ahead and pull a 10 out, right? So now it's a lot simpler. Now it's just 36 over 243, right? Now, I factored this. Did anybody else do something different?
No, I just
Levi,
factored
did you do
81.
something different?
Sorry, I just factored 243
Oh no.
to get 81 times 3.
All right. And then 6 times 6, right?
Mm-hmm.
I gotta make sure that's still on there. All right, so we have 10 square root 2 to the 2 times 3 to the 2 over 3 to the 5. Now, what do we do with exponents that are dividing?
Subtract them.
Okay, so then what do we get now?
-3. 3
Or over
10.
3 to the 9,
Yeah.
right?
Yeah.
Okay, cool. So what is, all right, so Levi, what is the cube root of 1 over 3 to the 3rd? It's kind of the same thing, right?
You're
and-
doing it a different way than me again.
Okay,
Oh
Let's
no,
see.
wait. Yeah, because I've already moved the square root to the top of the fraction and to the bottom.
okay. Here, I'm gonna move the piece of paper. You do yours down on the bottom there.
All right.
See if you can do it. So that was my answer.
Oh wait, that's the answer you got right there?
10 over 3 square root.
Oh, I
4.
got a different answer. Like no, it's the same answer. It's just in a different form.
Okay,
It's
so
in a
yeah,
fraction. It's in
technically
a fraction
mine's an
form.
That's right. Mine's an improper fraction, so you could.
Yeah,
do
the
it
whole thing.
differently.
The whole thing is just a The whole thing is just an improper fraction.
Oh, the whole thing is okay. Cool.
The whole thing. I got an improper fraction to the. All right.
Okay, what'd you get?
So I started with like. Well, I'm not gonna write this all down because it fills about half my page, but
Yeah.
I started with using the factors and I turned the cube root of 36,000 over 243 into 2 to the 5th times 2 to the 5th times
Okay.
3 squared times 5 to the 3rd over 3 to the 5th.
Ah, okay.
And from then it just kept on being a fraction until like, and here's my answer. Here's what I got. I got 10 to the 10 to the times the square, times the cube root of 4 over 3.
That's
It's
perfect.
the same thing, just in a different way of writing it.
Yep, I love it. That's perfect. So instead of going ahead and taking out the 10, you factored 36,000, which is perfectly fine. All right, so we have one more to do. Who wants to do the last problem, the hardest one out of the whole bunch? Square root of 56.
Oh, I
One.
can probably help explain it.
No, hey Miss Sarah. I finished
Yes.
number 6 in 3 steps.
Perfect. All
Literally
right, tell us the
3.
trick.
All right. And then all right. So and then Lola can do it afterwards if she really wants to, apparently.
Okay, that's fine. Yeah, we could have 2 different steps. 2 different
So
ways of doing it.
I took 56 over 126 and I divided them both by 15 and got
Okay.
4 over 9. The square
Love
root
it.
of 4 over 9.
That definitely
And
looks a
then-
lot better.
I can just equal that to the square root of 4 over 9. No, the square root of 4 over the square root of 9.
That's
And
right.
that
Yeah.
equals the square root, well, the square root of 4 is 2 and the square root of 9 is 3. So it's just 2/3.
Ah, I love it. I love the trick. Perfect.
That's the same thing I did though. Like
Yeah,
with
Is
more
it
you
steps.
copy
really?
off of me.
With more steps though.
What were your extra steps, Lola?
Well, Levi just erased all his, so I don't know what
Did
he
you
did.
divide both of those by 15 as well? Or did you do something else at the beginning?
14.
I just turned it into, okay, so I did just
Well,
make
see, no,
it-
she took the 14 and put it into the equation, so it's about a couple
No, I
things
didn't.
longer. Oh, that's not it? All right.
Yeah, what I did, I first got the thing and it became 2 to the 3rd times 7 over 2
Okay,
times
yeah.
3 to the 2nd and then times 7. Like I can draw it if you want.
Here,
Yeah.
I'll write it down. You tell me what it is. You did some factoring.
Yeah.
Like that.
Got it.
That's what I
Not
did. as
very.
well.
Not
Mhm.
very many people have joined this time. There's only 6.
Yep. I think it's
And then
the
at the end, whenever you like cross them out or whatever it is you do, it becomes
right. So you can reduce the same base numbers, right? So you get and you can cross out
get-
those 7s for sure.
Mm-hmm. Then you get
Okay.
2 to 2 over 3. Then you go back up and you have 4 over 9.
Okay.
And you turn
Yep.
that into. Then you turn 4 over 9 into. Oh my gosh, my pen is not working.
That's
yeah,
okay.
and
I'm doing it for you.
Then you turn it into the square root of 4 over the square root of 9.
Yep.
2 over 3.
And then you turn it into square root of 2 over square root of 3.
Good job. I like it. That's
That's
how
what
I
I
did it
goes
as
to
got
2
well.
over 3. Yeah.
That's how
Yeah.
I did it as well.
Awesome
Now
job,
I'm-
guys. I'm highly impressed. And Lola, you did the very last one. I mean, that's like you could go to high school. You should not be scared of math at all. You're very good. All right, good job, guys. All right, so what I wanted to do today, yeah.
Wait, Mr. I have an idea. Why don't you
Yes.
just open a whiteboard or something? We can all doodle around on it, whatever we want.
No, we're gonna do logarithms today. All right. Oh, there goes Emma. Everyone can see Emma. All right. So I wanted to bring this up today because of geology class. Okay. And do we remember when we were talking about earthquakes and the Richter scale?
Oh, yeah.
Okay. So most things that you don't realize actually are in logarithmic scale. Okay. So it's very simple and it has to do with square roots and squares. All right. So when somebody says, okay, example, we'll say log 2 of 8. Okay. This is what they mean. They mean the power you have to raise two to in order to get 8. So they mean, what power do you have to raise 2 to in order to get 8? So
You know,
what
I
would
was
be-
wondering. I know on a calculator it says log, and I was wondering what that is.
Yeah.
Yeah, so actually log came first because a lot of people use like a slide rule and stuff like that to figure out exponents and also figure out multiplication by adding certain numbers. All right, so they're using the log of numbers, and we'll make this relevant to geology class just in a second, but you can actually make numbers that are so far apart. Like, you know, when we talk about molecules in science, that's like 10 to the 23rd, right? Or time or compared to 10 to the 2, right? Those numbers are so vastly different that we have to scale them into a log graph. Okay, and we do this quite often. All right, so that's all that this means. It's just another way to write an exponential form. All right, so this is what we're going to practice, right? So let's say we have 3/5 equals 243. How would I write that in logarithmic form?
You would write log
Base what?
log base 3
Okay, of what?
243 equals 5.
Equals the 5. Okay, so this is how you go back and forth from logarithmic notation to exponential notation. Okay, and the only difference is, so we'll have, you notice on here, the base becomes a subscript. Okay, this 243 here, right? This is called the argument. Okay, a lot of people say, what's the answer, right? This is going to be called the argument. Okay, and then of course 5 is going to be your exponential, right? All right, so let's practice, guys. I'm gonna, write these in logarithmic notation. How would I write that?
Oh,
You would
We
write
always start with
log
log.
3 27 equals 3.
Okay, does everybody get that?
Yeah.
Okay, let's keep going. All right, we'll do another one. We'll say, all right, somebody else do that.
I'm gonna do it.
Grace, you want to do number 2?
Okay.
Okay,
Miss
how do we
Kara,
write this in logarithmic form?
Miss Kara,
Yes.
now this calculator says log 27 equals 1.31363764.
Yep. So you have to have a base on there, log 3 of 27. So you just couldn't put in log. If there's no base, it's gonna be determined 10 automatically. So you have to find on your calculator a way to write log with a base.
I think I have it.
Okay. What do we got?
Log 16, 2 equals 1/4.
That's right. Very good. Very, very good. All right. So all we're doing is we're saying
-1/2.
yeah. So we're just trying to find the exponent is what a log is. All right. So let's just do abstract numbers. So this would be what you would find in algebra class. X to the z equals y. Can somebody write that in logarithmic form for me?
Yes, I can. Someone's already doing it. Never mind.
Equals, you got it. Equals what? You had it, you erased it.
I'll let Emma
So
do it.
it's- Okay, go for it, Em.
Okay, let's see if I can get my pencil to work. There you go.
Perfect. Okay, so this would be logarithmic form. Let's go the opposite way. Okay, and then we'll do some real problems here. What if I said the log of 36 of 6 equals a half? Can somebody write that in exponential formation?
The calculator says 1.556302501.
So the answer to this is a half. Can somebody write an exponential?
Oh yeah, Emma's doing it.
That's right. So 36 to the half power, or the square root of 36 would be 6.
6.
Right. Okay. All right, let's try another log. So we're just practicing going from exponential to logarithmic. Okay. All right. Log base 3 of a ninth equals -2. How do you write that in exponential formula? Levi, you want to try that one?
Sure.
Emma, can you erase your 36 one?
Yeah.
Awesome.
I'm not so sure about this anymore. I find that with the fractions, I find it harder.
Yeah, it's supposed to look a little more confusing, but it's the same. So what would your base be in this problem? What's your base number for your
The t-
exponent? I mean, not
I did not mean to draw that.
3.
It'd be
Yeah,
like the 3,
equals.
1 9.
And does that make sense, right? Because 3 squared is 9, but with the negative, it's 1/9.
Mm-hmm.
Okay. All right. Perfect. All right, let's do 2 more and then we'll do some real life problems here. All right, 3. Let's see. We're gonna do no, we'll do that one. We'll try one more. I'm gonna do an algebraic one. All right, somebody put it in exponential formation. Yep. Super easy, right? Okay, so let's do a real life one. Log base 7 of 343. What's the answer, guys? So what we're saying to ourselves is, to what power can we raise 7 to in order to get 343? That's what we're saying to ourselves. So what would be the answer?
Three.
Calculate.
3.
3. Super easy, right? All right. What if I did log base 3 1 to 43. So what would I have to raise 3 to in order to get 1 over 243? That 1 over 243 should indicate some sort of negative number.
-3.
Ooh, you're close. 3 to the -3 would not be 343. Because remember, you're saying what is
sorry.
so
Negative
what is
5?
Problem.
yes? Was that you, Grace?
That was me, I guess.
3
no.
to the -5. So the answer would be -5.
-5. That's what I got too.
Yeah. Perfect. All right, let's do one more. Okay. Log, and this is a look. Hey, hello. Log 8 2. So there's a rule in here with that, but I want to see how you guys figure it out. So you're essentially saying, what power do we make 8 to in order to get 2? Is that a big number or a small number? Anybody got a guess?
What are we guessing on? I just have to go use the bathroom real quick.
Okay.
What, oh, what's
1
this?
over 3.
Right. So we would have to change the 8. So if you didn't have a calculator, you would change the 8, okay, to 2/3. Okay, that's another way to make 8. Now the rule is, if your bases are the same, they have to, and there's an equal sign here, that's the equation, right? This has to equal this. So how can 3x equal
Oh,
1?
it has to be 1/3.
That's right. Very good. You'd have to have this be 1 over 3.
Because 3 times 1/3 equals 1. So
That's right. Exactly. So then you can kind of visually see, oh, x has to be 1/3 in order to make that equal to 1. All right, I want to show you some cool stuff here. That's not.
No, it's the math
Where did I
problem.
put it? It's the math problem. Where did my math thing go? Oh, here we go. I know. I'm gonna do this one. Can y'all see that?
yes, ma'am.
Yep.
Oh, yeah.
Nice little picture. Here's a Richter scale from class. Let's see if I can make it larger. All right. Now, there was a newspaper that came out, and it says that one earthquake was a magnitude of 2, and the other one was a magnitude of about 8. Okay. So they said, okay, one earthquake in one place was a 2, and the other earthquake was an 8. And so they published that must be 4 times stronger than the 8. Is that correct?
No.
No.
Why is that? Right, because they didn't understand this was a logarithmic scale, right? So how many times stronger is a 2 from an 8, actually?
10 to the 6th times stronger.
10 to the 6th times stronger
Each
than
one
2.
is 10 times stronger than the one before it.
Each one is 10, that is exactly right. Each one, and do you see how difficult this would be to plot if we had one number going like 10 to the 1, right? All the way 10 to the 7, right? That's a lot of numbers. So you have to plot it on a logarithmic scale. So this person didn't understand logarithms and they went, oh, okay, well, that's 4 times stronger, that earthquake. No, it's not. It's much, much stronger. All right. All right. So if we had something else, let me see. I have another one. All right. Also, let's say this is in decibels. Does everyone know what we use decibels for?
Measuring sound.
Sound.
Yeah.
That's right. Okay. So this is how we measure sound. So guys, what would be a whisper? So that's 20 decibels.
20
all right?
decibels.
Yeah. If I had a whisper, that's 20 decibels.
Miss Tara?
All right. What about a jet? How many decibels is a jet?
Ooh, 140.
140.
decibels.
That's the kind of stuff that hurts your
Okay,
ears.
so if I didn't know math really well, I'd go a jet is 7 times louder than a whisper. Am I correct?
No.
Why am
Oh,
I
wait,
not
no.
correct?
Because it's probably another one like the
Levi.
Why am I not correct? So you could do the threshold of hearing if you wanted that instead of doing the negative intensity numbers. So if I just took my threshold numbers, right? What is a whisper?
20 decibels or 10 to the negative 10th intensity.
Okay, so we could do the negative number, 10 to the negative 10. And what does that mean? That means it's 0.1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right?
Yep.
That is a whisper. What is a jet, guys?
9.99999.
10 to the what? 2.
So that would just
Two.
be 100. That would be 100.
Okay,
Right.
correct. So what is the actual difference between this one and that one?
A huge number.
A very large number.
1 followed by a ton of zeros.
A ton.
1, 2, 4, 5, 6, 7, 8, 9. Make sure I did it correctly. 10, 11, 12. The difference is 12. This is 10 to the 12th times stronger or louder than a whisper.
Miss
So
Tara,
if somebody said, yeah,
what is instant perforation of eardrum?
The,
I'm guessing that's
when your eardrum bursts.
that's right.
That would be loud.
And
When
who
your
does-
body
and
no
while
more
we're
hearing.
while we're looking at our sources, who is familiar with music sound? And can you tell me what pianissimo means?
Me. Means
Oh,
You
quiet.
have
Pianissimo?
something in pianissimo. Is that loud or soft?
Soft.
That's
Soft.
really
Soft.
soft.
That means you're gonna play that piece very soft. Has anyone played piano forte before? Forte? If so, how do you play it? Loud or soft?
Loud.
Loud.
Yeah. There's your fortissimo sound. Okay, so it's a little louder than a normal conversation. So that you see that a lot in music because it has to do with how loud you're going to play a piece. So you could actually say, all right, how much louder if you play something in piano forte, which is pianissimo, 40 decibels compared to piano forte, which is 100 decibels. So some people would go, oh, like 2.5 times louder. Is that true?
Nope.
It's never 2.5 times louder.
Well, I was kind of rounding.
But Miss Tara,
Yeah.
if the threshold of pain is 130 decibels, then how come it's still, shouldn't it be 10? Shouldn't it be also 10 to the 1? Because shouldn't it be like like, shouldn't, if it was
The
120,
threshold of
wouldn't it be
hearing?
10? No, the
So-
threshold of pain, shouldn't that be 120, not 130?
I am not sure. Wait. Okay, so you look at the threshold of hearing. That's going to give you your number. You're right. Okay, I see what you're saying. It doesn't seem to be corresponding with, it looks like it's going up by 2, except for right there.
Yeah.
So there must be some sort of, they realize that it's not high enough. 10 to the 12 is not high enough for pain. They had to make it 10 to the 13.
More pain.
That's right.
Oh.
But you're right. That's kind of the oddball number, right? That might be where they're starting their baseline.
What is
besides-
the threshold of pain anyways?
And that's what I mean. I'm not sure how they got that.
I know what the threshold of hearing is. It's like where there's no sound at all. They have, like,
That's
those-
right. Yeah.
But
I
what is the
wouldn't put
threshold of
the
pain?
V
No,
in
I'm
the
gonna look that
scientific
up right now. I'm gonna look that up right now.
I wouldn't
pain.
want to
It's
be the
a
person to try this out.
it's pain in a threshold.
That's right. When do you start feeling pain? Because it could be just that. They've
Every
averaged a bunch
day.
of people for pain. And they got it around somewhere around
Oh
130.
no, that's how much it takes to make your ears hurt.
Right. Exactly. That's what I mean. They might have surveyed some people in that study.
That's the
They, like,
average.
haven't hurt
That's the
yet.
That's
average
kinda
decibels that it
mean.
takes to make your ears hurt.
And they had to make someone go deaf to get it to 160.
Yeah, but that looks
decibels.
like their
Let's name it
baseline. It
160
looks like their
decibels.
baseline because it's just 10.
Poor person.
So
That's
you'll
mean.
use this logarithmic scale a lot. You'll use it a lot in science. Mr. Michael uses it all the time in engineering. So if you go in any sort of science and engineering thing, I've used this a lot, especially when you're making really small things, right? And trying to compare it to like atoms to molecules. These things are vastly different in size. And you have to, if you guys want, there's actually logarithmic paper that you have to get. So if you go into engineering, that's the type of paper you would have to get. And then you obviously see it in your graphing calculators, right? Let me see if I see now. Let's see it. Any questions right now about the logarithmic scale? It's pretty easy once you know how to go from the exponential notation to the logarithmic notation.
Nope.
'Cause all
Lola
you're
has a
doing is
blanket.
finding the exponent. So I'm going to give you guys 6 more problems this week, and they're all going to be in log form. Okay. Do we want to do the first one first, so we're clear on what this is? Or you guys just want to show me next
I'm
week?
already clear on what this is.
Questions?
Nope. Does
Okay.
the threshold of pain include absolutely hitting your left ear on a wall? And now every time you touch it, it hurts? Because
Someone
that's
landed
what
on
I
my
did,
ear.
and I don't know if I should see a doctor or not, because literally I can't touch the outer ear without hurting.
That would be different.
Why'd you slam your ear against the wall?
Accident.
I was
guessing.
jumping off the I was
Jumping off the roof.
trampoline, and I rolled. I jumped off the trampoline in the living room, and I rolled on the couch and hit my ear on a little wooden column to the balcony, and that hurt.
Someone landed
Well,
on
I
my
hope
ear.
your ear feels better.
I don't know if it's going to.
All right.
Can you still hear though?
I can still hear, yes. It just hurts.
Hey guys, well, you guys did a great job. Good job, Mark. It was a pretty easy class today. Has anyone else done logarithms before? Has anyone started
No.
that?
No, I've seen it on a calculator before.
No.
Yeah. Well, that's the beginnings. You'll use them all the time. A really, really simple one is, have you ever heard anyone say like, I make a 6-figure salary or something?
Is that supposed to be a joke?
No, they say that quite often.
Apparently, I'm not often enough
It
because
means
I have never
there's
heard anyone
one
say
with
that.
5 zeros behind it, right? So you make
Yeah.
$100,000 a year or some amount of $100,000. But
I
it's
have a $2 check
easier.
a year.
People like to use this logs in daily talk because it's so much easier to visualize like how many. Let's look it up. Let's ask Siri. Say Siri.
Siri.
He's always
How
listening.
many seconds are in $1 million? Like if you convert 1 million seconds to years. Okay. So let's see. Where do we go? So if you wanted to make a second for every dollar, how many years would that be? It's like
You
something
mean
like
$1 every second?
yes.
And you made $100,000. First,
A
we would
million.
have to know how many seconds are in a year.
That's right. So how many seconds are in a year? How many seconds are in a year?
I have no idea.
Let me look it up.
Levi, you're muted.
31
Levi's saying
million
all the
seconds.
answers.
That
Levi's
is
muted.
depressing. That is
So
Levi's
very
31
saying
million
everything of
seconds
it.
are in a year, right? So we go.
31 million,
525,600 times
536,000
60.
Okay, so you could have $31 million every
there
second
are
for a year.
31,000.
So then you'd go, people can't seem to wrap their head around $1 trillion because they think, oh, that's just a couple more times more than a million, right? And that's not true. So it's
10
like,
times more than a million. And wait. So
So-
there are 31,536,000 seconds in a year.
uh-huh. So then
That's a
you
lot of
go, it's like, then you go, okay, $1 trillion and you get every second. How many years would that equal? So that would
Oh, wait,
be
no,
like,
wait, give me a second.
that
I'm
would
about
be
to go with a book.
31 years, right? Like now you're multiplying by 10 many, many times over. It's hard for people to wrap their brain around what $1 million is versus $1 trillion. So they tend to think of it in logarithmic form because it's just so vast. It's exponentially more, right? Is everyone calculating that?
Miss Tara.
How many
So I
years?
have
are
a
trillion
book
seconds?
for this. Books are better. And it
Okay,
looks
so $1 trillion seconds is 31,000 years.
I don't
I'm
really
sure.
want to work for 31,000 years.
Right. But let's count, let's say each one of those seconds is $1, right? That's vastly different than a million seconds in years is less than a year, right? $1 million.
if you
is
earned
less-
$1 every second, it would take 12 days to become a millionaire, but you need 31 years to be a billionaire.
See, that's the difference in money. So when you start hearing people going, oh, they're billionaires, oh, they're trillionaires. It's so vastly different than a millionaire. People can't understand how different it is.
So are they really billionaires or
Oh,
are they really
yes.
just millionaires?
Yeah, well, that's what, Elon Musk and
No,
the
there's no
Jeff
trillionaires
Bezos
out
guy.
there.
Yeah, the Jeff
Yeah,
Bezos
there's only like what, $33 trillion in the world.
Can do it, baby.
So if
Yeah.
someone was a trillionaire, they'd have 1/3 of the world's money. Well, maybe not
and there are
1/3,
trillionaires.
but they'd have 1/33 of the world's money. That's the best.
Yeah.
It's still a
Wait, there are
trillionaire.
trillionaires?
No, there's no
So-
trillionaires.
Where are the
But
quadruplinaires?
When you hear, like, when you grow up and you hear, oh, we have a budget, the United States, of $1 trillion or something, people think, oh, that must be like $1 million.
It
like
is not.
triple
We
a
spend like
million or something.
900.
That's just not
USA
true.
spends like $999 trillion on the military every year.
That's right. So that is unfat. Like, our human brains cannot understand that large of a number, right? Because it would take
This
us, if we
malarkey.
spent $1 every second, it would take us 37,000 years to spend that money.
Well, our brain cannot comprehend this malarkey.
That's right. So in order to put it where people can understand it, we have to use logarithmic scale in order to plot this.
You guys
The
are reading
numbers
about
are
it.
so vast, which is why in scientific notation, we have 10 to the something exponential, right? Like, if an atom is so small, we cannot comprehend it. We have to say it's 10 to the like -23 or something, the number of whatever a mole is, 6 times 10 to the 23, so, or -23. We'll learn. All right, well, that's the class for today, guys. Good job. Now you just have to try to make your own logarithmic scale. You can make it with any two numbers that are quite vast, right? Just like someone did with a whisper and a jet in decibels.
Yep.
Most I'd get to is probably a log practice problem.